This webinar is being recorded.
Hi, everyone. I know people are joining from different parts of the world. So good morning to the ones who are joining us from the western part of the world, and good afternoon and good evening to the ones who are joining from the eastern side. We will wait for a couple of more minutes and wait so that everybody joins, and then we'll start. Julian, just checking if you have already joined, and I can see a raised hand. I would urge everyone, if you have any queries or doubts, can you please put it in the Q&A that you can see, and we would address it. If not right away, maybe we'll address it in the intermission. Yeah. Good to see you, Julian. We're waiting for you. So what we have done, everyone, like we do in our webinars, just to avoid any technical disruptions, we have recorded the session and we are going to play it for you. But if you have any questions, feel free to use the Q&A section. We can type it and answer it out right away because Julian is always available there. And in case it's a very nice question that we can address to the entire audience, we would take it up when we have a short break in between, or maybe once the entire webinar is over. I have had the privilege to see the video that Julian has prepared, and it is absolutely information rich. So without taking much time, I would start today's webinar. Julian, just let me know if it's visible and playing.
Welcome everyone. Yeah, visible to me.
My name is Julian Nagel.
Thank you.
I'm the product director for Reactore. And for almost 15 years, I've worked across a range of mining digitalization projects: fleet management, production systems, mine logistics, systems integration, and the design of mine-wide digitalization platforms. That also means I spent a lot of time in the trenches, firsthand in control rooms, weighbridges, plant offices, and port environments, seeing where information flows well, and more importantly, where it starts to break down. The session will run for about 60 minutes, and I'm going to split it into two parts essentially. In the first section, we'll focus entirely on the industry problem, where pit support visibility breaks down, why those gaps occur, and why local visibility does not necessarily equate into end-to-end performance. We'll then pause briefly for a few questions and discussions before moving into the second half, where I'll introduce Reactore and Mine 1 and look at some practical ways these challenges can be addressed, including the concept of digital threads, connected operational context, exception management, real-world examples, and some practical implementation guidance. We'll keep the final 10 minutes or so for a broader Q&A, but please feel free to put questions into the Q&A panel at any point. And one promise up front, this is not a 50-minute product demonstration. At Reactore, we really try to start with the operational problem and work backwards to the technology, not the other way around. So before we talk about Mine 1, we first need to properly understand the problem we are trying to solve. And with that being said, thank you again for joining. Let's get started. We'll structure today in 6 short blocks. First, we'll frame the pit support visibility problem and define what a connected operating model actually means. We'll then pause briefly for discussion before moving into our Reactore and indeed Mine 1 address these gaps. And from there, I'll show a hypothetical scenario, an actual deployment, and then close with some practical principles around KPIs, control towers, AI, and digital maturity. We'll keep the final part open for all of your questions. The visibility paradox most mines live with. This is the contradiction I want to start with. A modern mining operation can tell me with remarkable precision exactly what one truck is doing at any given point in time. We can know where it is, whether it's loaded or empty, how long it has been queuing, its payload, its fuel consumption, and in many cases, even its mechanical condition. That is visibility, and the industry has invested heavily to achieve this. But ask yourself a slightly different question. Will tomorrow's shipment leave the port on time? And suddenly the answer becomes much more nuanced and difficult. Now we need to understand production against plan. What is sitting in the ROM, what the plant is producing, what saleable inventory is actually available, what has been dispatched, and where the transport is, what is already at the port, and what is committed against the customer contract. Very often, answering that question still requires somebody to make a phone call, open a spreadsheet, send an email, or reconcile several different systems. And that is the paradox. Both capabilities can exist in the same organization. You can have excellent visibility within individual parts of the operation, while still having poor visibility across the value chain. So when we talk today about end-to-end visibility, I'm not arguing against that mines need more data. Most mines already have enormous amounts of data and in fact only use 10 to 20% of their data meaningfully. The challenge is creating the connected operational context that tells us how an event in one part of the operation affects everything downstream. Because ultimately, the mine is not judged on whether one truck achieves a good cycle time. The business is judged on whether it delivered the right tons at the right quality to the right customer at the right time. And the gap between local operational visibility and end-to-end business visibility is what the rest of the session is about. If I asked your operation right now, how many saleable tons are genuinely available for the next shipment, how long would it take to get one answer everyone trusts? Think about that for a moment. So on the previous slide, I introduced the paradox. A mine can have very good visibility inside individual parts of the operation and yet still struggle to answer a simple end-to-end business question. This slide is really about defining that distinction. On the left, we have local visibility. This is the kind of visibility most mining operations already do reasonably well. We can answer questions like, is this truck loaded? Is my crusher running? Did the shift achieve its tons? Is this excavator available? Those are all important questions. They are operationally necessary, and the systems we use to answer them have created real value. Mine 1 produces those very systems. But there are still questions about a specific asset, process, shift, or department. Conversely, on the right-hand side is the concept of end-to-end visibility. This is different. It asks what activity in one part of the value chain means for everything downstream. Will the vessel sail full and on time? Where is the current constraint? Is the contract at risk this week? What did today's operational performance change further down the chain? And these questions cannot usually be answered by a single system. And that is the important point in the middle of the slide. Most mines already own some or all of these technologies. FMS, GPS, telematics, SCADA, ERP, etc., etc. The technology estate is already substantial. The problem is that each system tends to provide a very good view of its own part of the operation, while the connection between them is often weak, delayed, or manual. So you can end up with a multiple accurate local views, but still no single end-to-end operating picture across the estate. That is why I like the distinction at the bottom of the slide, where local visibility measures activity, end-to-end visibility connects activity to an outcome. And ultimately, that is the shift we are talking about today, moving from knowing what happened in each of the mine to understanding what those events mean for the final production, logistics, and commercial commitments. Perception versus reality. Now, you can ask 5 departments where the bottleneck sits, and you'll probably get 5 different answers. Operations may blame logistics, logistics may blame production, commercial may question the inventory, and finance may point to the reconciliation. The key point is that none of them are necessarily wrong. They are each seeing the problem from inside their own silo. Now, in reality, the reoccurring weakness is usually the handoff between those silos, where information becomes delayed, loses context, or turns into a different version of the truth. So the better question is not which department is failing, it is where is the connective tissue between these departments breaking down? And most mines have strong silos connected by weak handoffs. This slide shows the core idea behind this webinar. Pit support is not a series of isolated departments. It is one connected operating system. We often manage these stages separately. You have your mine planning, then your pit operations, hauling, stockpiles, plant logistics, ports and reconciliation. And operationally, that makes sense because each part of the chain has its own team, processes, and systems. Fair enough. But the material does not experience the operation in silos. It moves through one continuous journey. What starts in the mine plan becomes activity at the face, then load and haul, then ROM stock, then processing, then product stock, then ultimately dispatch through road or rail, through the terminal and port, and ultimately to the customer, before finally being reconciled commercially. The important point is that different mines and different commodities may use different versions of this chain. Some may be simpler and some way more complex, but the principle stays the same. Every step is connected to the next. And that means if one part of the chain changes, the downstream consequences should be visible immediately. So this is not just a process map. It is a reminder that mining performance is not determined by how well each department works in isolation, but how well the whole value chain works together. So in closing, if pit to port is one connected operating system, the next question is obvious. Where does the continuity actually break? And in practice, it tends to break in very predictable places, at the handoffs, between stages, systems, and teams. So in saying that, this slide, I feel, is really at the heart of the discussion. Because if we accept that pit support is one connected operating system, then the question becomes, where does the connected system actually break down? And what we see repeatedly is that the failure is rarely inside one department. It happens at the points where material, information, and accountability critically move from one stage to the next. At the pit, the operation may know exactly what happened during the shift, and the quality of that information matters enormously downstream. You can take something as simple as payload. If payload is assumed rather than measured, the problem does not stay with the truck. It gets passed down. Every downstream ton figure now inherits that assumption. The stockpile quantity inherits it. The production figure inherits it, and the logistics plan inherits it. Eventually, commercial reconciliation has to explain it. So a small data quality issue at source can become a much larger business problem later. Then we move from the mine into the plant. Here, one of the most important things we can lose is material identity. Look, a truck can leave the mining face with a known source, known material, classification, and perhaps a known grade. But the context of that may be lost when the material reaches the RM pad or stockpile. It effectively becomes an anonymous ton. Now the plant knows what it received, but not necessarily exactly where it came from or what commercial commitment it ultimately supports. And from that point onwards, reconciliation becomes retrospective and oftentimes difficult. At the plant and stockpile stage, the problem becomes certainty. How much saleable material is actually available? What grade is it? Can it be blended? Or how much of their stock is already committed? Production may have one view of availability while logistics is planning against another. Both teams can be working correctly from the information they have and their perspective, but they are no longer actually working from the same operational reality in many cases. Finally, we will move on to transport. Now, there is another very common gap. Movements are tracked and orders are tracked, but the two are not necessarily connected. You might know exactly where a truck or train is. You might also know exactly what the customer order or shipment requirement is. But if the movement is not digitally linked to that specific commitment, then you still cannot answer the question, is the material for the shipment actually on its way? That is the difference between asset tracking and end-to-end contextual visibility. At the port, the consequences become much more expensive. The vessel schedule may have been committed weeks in advance, but the mine output feeding that vessel is being influenced today by equipment availability, geology, weather, plant performance, stock levels, and transport capacity in other areas of the value chain. If those plans are being maintained separately, the mismatch is often discovered only when the options for intervention have almost disappeared. And that is when we start talking about demurrage, emergency transport changes, stock shortfalls, and last-minute commercial decisions. And then finally, commercially, the most obvious symptom appears. Two different numbers for the same shipment. This operational view in terms of the tonnage will say one thing, and the invoice to reconcile tonnage will say another. And suddenly month-end reporting becomes less about reporting performance and more about explaining why these two versions of reality do not agree. So although these look like 6 different problem areas, the underlying failure is actually remarkably consistent and systemic. Context is being lost at the handoff. The material moves, but the information attached to that material does not always move with it. The operation commitment moves, but the systems supporting that commitment do not always remain connected. And that is the point I want to land on this slide. Now, what this slide is showing is how a relatively small operational deviation can actually change and form and its scale and size as it moves downstream, essentially the butterfly effect. At the operational level, the issue may look quite minor. A truck queues for 20 minutes, a loading unit sits idle, fuel burn increases ever so slightly, and your utilization drops. At that point, it feels like a nuisance, something the operations team may try to recover during the shift. But if that disruption is not corrected, it does not simply disappear. It moves into the next part of the chain. Now it becomes a production variance. You may have a shortfall against plan, your inventory position may become less certain, your stockpile balance may be wrong, your grade profile may begin to move away from what was expected. So the same issue that started as minutes in the pit is now being expressed in tons, inventory, and quality. Then it reaches logistics. Now the consequences are different again. Transport slots may be missed, rail or trucking capacity may be used inefficiently. Material may arrive at the terminal later than planned. You may have to expedite freight or resequence movements. At this point, the problem has moved from variance into cost. And finally, it reaches the commercial end of the chain. And this is where the impact becomes very visible. You can incur demurrage, mines can expose themselves to contract penalties. Working capital can remain tied up for longer. Invoicing and cash conversion can be delayed. So the upstream deviation has now become margin erosion, essentially the biggest business key performance area. And that is why I like the progression at the bottom of the slide. Nuisance to variance, variance to cost, and cost to margin erosion. The issue is not that one 20-minute queue automatically causes demurrage. That's definitely an overestimation. The point is that repeated, unmanaged, and accumulated deviations will potentially result in this outcome. And if there is poor visibility across the value chain, the organization does not see the cumulative effect until it has already become too expensive. And that is the hidden cost of weak end-to-end visibility. A local team may see small operational issue. The business may eventually experience a bad commercial consequence. And the value of connected visibility is being able to recognize that trajectory early enough to intervene before the issue changes currency from minutes to tons to costs and ultimately to margin. And that brings us to my next point, and an equally important issue: timing. Even if the information eventually reaches the right people with the right context, it is of limited value if it arrives after the opportunity to act has passed. A production shortfall identified as month end is history. The same shortfall identified early enough to adjust dispatch, stock allocation, or transport planning is actionable. So the next challenge is not just about visibility, it's decision latency. How quickly an event becomes information and how quickly that information becomes action. And on that very point, this slide introduces the dimension of visibility relating to timing. It is not enough to know what happened. The information has to reach the right person while there is still an opportunity to influence the outcome. If you look at the typical workflow at the top, this is still a very common situation in mining operations. An event happens, somebody captures it manually, it finds its way into a spreadsheet and then perhaps into an email. Different teams reconcile their numbers, a meeting sometimes takes place, and eventually a decision is made. The problem is that by the time that decision is made, the operational window may already have closed. So the organization has visibility, but it is essentially historical visibility. The connected workflow underneath, however, is fundamentally different. The same event, perhaps is captured automatically. It is contextualized against the operation and assessed against defined rules or expectations. If something is outside tolerance, it becomes an exception. That exception can trigger an alert, a decision, and ultimately an action, actionable intelligence. The important point here is that we are shortening the distance between something happening and critically somebody being able to do something about it. And I want to make another distinction because real time gets used far too casually in our industry. Reactore Mine One is all about real time data when needed. But I will say that not everything needs to be real time. A dispatch decision may need information in seconds or even minutes. A production shortfall may be perfectly actionable at the shift level. Inventory recons may be daily, and certain commercial or financial processes may only need month-end information to act upon. So the objective is not to make every data point real time. That would often add cost and complexity without adding value. The correct question is, how quickly does this particular decision need the information? And then we design the information flow around the decision window. And that is really the message at the bottom of the slide. The objective is not just broad-based real-time data. It is the right information at the point where a decision can still change the outcome. Because once the intervention window closes, visibility is useful for reporting and fishbone or root cause analysis, but it is too late to protect the actual operational result. And this is where we run into the next dimension, the next problem. Even if the information is contextually put together and it is timely, it still has limited value if the different systems involved are operating at separate islands. So the next question becomes, where does all of that operational information actually live? And how well is it connected? This is the point where I would challenge everyone to think about their own operation. Looking at these systems across the top, I won't list them all, but your typical mining systems from mine planning through to fleet, SCADA, GPS, weigh bridges, and beyond. How many of those do you already have? For most operations, the answer is probably at least half or more. Now ask the most or more important question. How many of them actually talk to each other without a person in the middle? Usually it is only one or two pairs. And that red band in the middle is probably the most honest version of a mining architecture diagram that you'll see. Because in reality, that integration layer already exists today at most mines. It is just simply made up of Excel, email, phone calls, radio comms, manual reports, and critically, individual memory. That layer is often, from my experience, incredibly skilled. There are people in the mining operations who know exactly which spreadsheet to open, who to call, how to reconcile two different numbers, and how to interpret what the systems are not telling them. And I don't want to diminish that work, because those spreadsheets and manual processes exist for a reason and often what keep a mining operation ticking away. Somebody solved a very real operational problem that the underlying systems did not solve. The problem is that this kind of integration does not scale particularly well. It only works until that person who understands the process is available or is perhaps on leave. It works until production doubles, or it works until another site is added, or really until an auditor walks in and asks a very simple question: how exactly was this number derived? And that is where the fragility becomes visible. So the objective here is not to remove the intelligence that sits in those people and processes. The objective is to capture that intelligence in a structured way and move it into something more durable, shared, and automatic. And that is what I mean by an operational integration layer, a shared contextual model that allows information from all of these systems to relate to the same assets, locations, material, trips, stockpile, shipments, and ultimately commercial commitments. Most importantly, it sits between the systems you already own. It is not about replacing them. It is about removing the dependency on people having to manually stitch the operational together every day. So if the real issue is not the absence of data, but the fact that it is disconnected, the next question is, what does a connected operating model actually require? Because simply integrating systems or putting everything into a dashboard does not necessarily solve the problem on its own. We need a sequence that takes us from raw operational events through integration and context, all the way to decisions and action. And that's what the next slide will be about. This is really the engineering backbone of the discussion. Dashboards are simply an output, not the foundation. There are really 7 steps here, and what I have seen repeatedly in my experience is that digital visibility programs tend to heavily overinvest in step 1, the capture, the data acquisition side, and step 4, visualize, while underinvesting in step 3, contextualize. Capture is largely a solved problem. We have so many types of sensors, mobile devices, GPS telemetry, OEM systems, SCADA, and operator inputs, which generate enormous amounts of information. Integration is harder, but it is a well understood discipline. Reactore does it every day. APIs, industrial protocols, database integration, and messaging technologies are mature. Technically connecting system A to system B is rarely actually the fundamental challenge anymore. It is an important step, but the real issue is contextualization. And that is why I've deliberately highlighted it here. Because the data point by itself does not tell you very much. Take something as simple as a payload of 52 tons. On its own, that is just a number. But if I know that those 52 tons were carried by a particular truck, or loaded by a specific excavator, originated from a defined mining block, consisted of a particular material type or grade, we would and delivered to a particular stockpile during a particular shift, and ultimately contributes towards a particular shipment or customer commitment, then that same payload becomes an operational fact. And that data becomes as valuable or closely as valuable to the actual mining commodity itself in many ways. Now I can aggregate it, reconcile it, I can trace it, forecast, form it, and defend it. And there is a very practical test for whether an operation has achieved this. Ask the system, how many tons of saleable product currently in the yard are committed to the next vessel, and where did those tons originate? If the system can answer that question directly, you have operational context. If somebody still has to open 3 systems, call another department, and assemble the answer in Excel, then you may have integration, but you do not necessarily have the context. Once that foundation exists, you can get to the more advanced stages where visualization becomes more useful. Dashboards, maps, and control boards can show a coherent picture rather than just simply displaying disconnected metrics and looking fancy, but not actually having substance. But visualization is not the end goal. The next step is detection. Nobody is going to sit in front of a dashboard for 8 hours waiting for something to go wrong. The system should be watching the operational continuously and drawing attention to exceptions. A threshold breached, production falling behind plan, inventory below requirement, or a shipment becoming exposed. Then comes the next layer, which is act. This is another step that technology programs often overlooked. If a system identifies a problem, but the response still happens through a phone call, WhatsApp message, or some other spreadsheet, then we have only digitalized the observation process. If visibility does not ultimately lead to a change in dispatch, a change in your schedule, your workflow, logistics plan, or an operating decision, then we have built what I sometimes call an overrated, expensive observational deck. And finally, once we have that, we can look at the layer of analysis and the way it means to improve the mining operation. And that positioning is deliberate because optimization, predictive analytics, and AI sit on top of everything that comes before them. They can enhance a well-connected, contextualized operating model, but they cannot compensate for the absence of one. This is a critical distinction because a lot of people will be lured into looking at predictive analytics and AI because they are fantastic technological capabilities that we have today, but the house needs to be built on a solid foundation. So the key point on this slide is very simple. Integration creates connectivity. Context is what turns that connectivity into insight-driven quality decisions, what I like to call actionable intelligence. So in my view, step 3 is where most visibility programs either become generally operational or remain a collection of very impressive but less practical dashboards. This is a good point to pause and make the session a little bit more interactive. We've deliberately spent the first part of this webinar on the industry problem, where pit support visibility tends to break down, why local optimization is not enough, and why the real issue is often the connective tissue between the silos. Before I move on into how Reactore approaches these challenges, I'd like to hear from you all. There are 2 simple questions on the screen. The first, where do you see the biggest visibility breakdown in your own value chain? The second is what makes end-to-end coordination difficult in your operation today? Please feel free to use the Q&A panel or chat, and if no one jumps in immediately, that's fine. I'll offer a couple of examples to get us started. Thank you, everyone, for joining again. This is now me in real time, and appreciate the patience you've shown to endure that. The best half will be coming now. So if anyone would like to speak up from their own anecdotal experience, feel free, or I can just jump in with a few examples based on my own experience. We still have another 20 or so minutes of the video to go before we hit the final Q&A session. I do note that some people have raised some questions. We will definitely be answering them at the end. In fact, 1 or 2 questions will be answered actually as part of the presentation itself, which I'm glad to see. But yeah, I think Patricia, maybe I can, as promised, touch upon those areas. I think essentially, what are the 2 major questions? Where do you see the biggest visibility break in your value chain? And that can be many places, depends from operation to operation. It could be between production inventory, where material is mined and moved, but there is sort of no single trusted view of what is actually available, where it sits and whether it is actually sellable. And on what makes end-to-end coordination difficult in the operation, well, that's disconnected and fragmented systems. You've got your fleet, production, inventory, all maintenance, all the systems, and they all exist, but not in one connected operational context. And yes, sometimes there is our lack of systems, and one of the first things Reactore does is we fill in those gaps. But ultimately, once the systems are present, you've got to get them to integrate together into one sort of cohesive operational layer. I see someone has raised a point. I have observed the common gaps: synchronization of loading and hauling machines. Either truck is in the queue or loading machine is idle. Yes, that's a very good point, because that is a good example of operational inefficiency on the micro scale, which within a silo. And in the mining sector, you have professionals and teams and organizations that work within that silo and will observe lots of inefficiencies within the load and haul area. And that is definitely valid and something that Reactore and Mine One solves. And definitely the synchronization and optimization of your haul cycle and your loading and queuing with say dynamic dispatch algorithms, which we do, will solve that. But let's just say that you do solve that and your mining silo is performing very well, but at your plant sector and logistics, there are a lot of bottlenecks. So you'll be pushing through good throughput, but it means nothing, if the valves are open, and then further downstream, there are bottlenecks. So that is why the purpose of this presentation is to talk about the bigger value chain topic, but that's definitely a very common gap raised there, synchronization between loading and hauling machines, where either the truck is in the queue or the loading machine is idle. So thank you for that input. So I think, Pratish, I think I can go on and on about the gaps, but I think the next section of the webinar should be more interesting in terms of what can we do about it, I think.
No, definitely. Definitely. That's one thing. And thank you, Mr. Bhaskar, for giving that question. That's a lovely question.
Thank you.
And if anybody will just wait for a few more seconds, if anybody has any question to add or want to raise your hand for getting an opportunity to come and speak directly, to share your experience, we'll just wait for a few more seconds before I jump into the next section.
There was a question raised. If a mine wanted to start improving its end-to-end visibility today, what would be the first practical steps you would recommend, and how quickly could one expect to see measurable value? So that is a fantastic question, and it will be addressed actually in the next section. So I would like to point that out, but certainly we will give some practical steps on how that works, the concept of the digital thread, creating a digital twin of your operation, integrating the system, mapping out a physical process and a corresponding data flow, and the real ground level practical ways to actually solve this, and actually how you can get ROI in the earlier part of the digitalization maturity curve. You don't have to get to the AI and analytics level to start getting an ROI. An ROI can be achieved in the early stages, which you'll see in the second part of the webinar. So thank you for that question, Mr. Hendricks. I appreciate it. And I think with that being said, I think Mr. MC, I think we can proceed with the second half, unless anyone wishes to raise their hand or say something. This is, of course, an open-ended webinar. We welcome any further inputs.
Yeah, I don't see anything else, and I was just thinking, good that we recorded, because when I was trying to turn on the video, it started buffering. So it's good we are avoiding those technical glitches. So I'll just turn off my video for now, and we'll get back to the next part of the webinar. Thank you.
You may have noticed that I didn't start the session with a company profile slide, and that was actually deliberate. At Reactore, we prefer to start with the operating problem and work backwards to the information and decisions required, and only then do we start to talk about the technology that makes all of these things possible. So even though we are a technology company and we can achieve all of these things, this is the way we prefer to operate when approaching the challenges faced by the mining sector. And the reason for this is simple. In mining, the technology only matters if it helps solve a real operational problem. So at this point in the discussion, having looked at why mining logistics break, where visibility gets lost, and what an end-to-end operating model actually requires, it probably makes sense to briefly explain where Reactore fits. For those of you who don't know, Reactore is a mining technology company. We focus on operational systems for mining, that being fleet, production, maintenance, logistics, and the integration between them, as well as the commercial edge of the value chain and beyond. The reason we frame this problem this way is because we keep encountering it in practice. Almost every engagement with a mining client starts with what appears to be a request for one module or one system enhancement, and very quickly becomes a conversation about the hands-off and the handoff, I should say, on either side of it. A client may ask about fleet management, for example, but the real challenge turns out to be how fleet data links to their stockpiles, or the plant output, logistics movements, or shipment commitments. Or they may ask about logistics visibility, but the issue begins much earlier in how operational data is structured and connected upstream. That is why these operating principles matter. So the first principle would be mining first. We build for mining operations, not generic industry. The operating model has to reflect the way mines actually work. Shifts, phases, trips, stockpiles, parcels, shipments, not force mining into some sort of generic enterprise template. The second principle is connect. First, don't replace. This is both a technical and commercial position. Now, most mines already have invested heavily in systems that work reasonably well, at least. Your planning systems, OEM systems, maintenance systems, ERP, SCADA, and others all represent real investment. So our view is that the priority should usually be orchestrating, connecting those investments, not launching another expensive rip and replace program with all the risk that comes with it. Now, that being said, there are certainly viable cases where you have legacy systems and they need to be replaced with more future-proof systems, and we fulfill that role as well. But that is more of the exception than the rule. And our third operating principle is configured, not rebuilt. Mining processes are not uniform. As I always like to say, they're like fingerprints. They all look the same, but they're all completely unique. For example, two mines in the same commodity, same country, even under the same owner can still run different dispatch logic, different workflows, and different operating rules. So flexibility in implementation really matters. And when we talk about a low-code foundation, what we really mean is that Mine One is built upon a platform which allows us the ability to configure processes and workflows, rules and visualizations and screens on how the operation actually runs. And to be able to pivot and change that quickly when the operation changes without waiting for lengthy software development cycles or changing lead times. And this is where Mine One really fits in. Mine One is the best, I would say, in terms of its ability to adapt to unique mining operations. I would say it's probably the most customizable, flexible platform on the market in the mining software space. And Mine One is the way we make this kind of operating model tangible. It provides the operational layer that connects the systems, equipment, people, processes into a shared operating picture. So practically speaking, that means shared operational context across mining, processing, logistics, integration with existing systems, your equipment, and third-party operators and systems, configurable workflows and rules, and the visibility, exception management that we discussed before, your alerts and decision support systems needed to act on what the data is telling you. So while this is not really a company biography slide, it is simply being placed here to point out that I wanted to show that the framework that we've been discussing is not just a theory. It is a practical way of approaching mining digitalization, and it is through this lens that Reactore and Mine One are designed to help make end-to-end visibility achievable. So we've looked at the problem and we've introduced where Reactore and Mine One fit. But the next question is a practical one. What does the solution actually look like? Well, it starts here with what I like to call a digital thread across the value chain. Every physical movement should leave a corresponding digital event. From the source block through loading and hauling, stockpiles, processing, transport, port, and ultimately the customer. That thread gives us continuity and traceability. Where the material came from, where is it now, how much is available, and what it is committed to, and whether we are still on schedule. And this is also the foundation of a practical digital twin. Now, you may have heard about the concept of a digital twin before. And a digital twin is not simply a 3D model of the mine. It is a continuously updated digital virtual representation of your real operation. Its assets, materials, locations, inventory, movements, and commitments. So the relationship is simple. The digital thread connects the events. The digital twin represents the current operational state. Together, they create the shared operational context needed for mining, logistics, your commercial and finance, to work from the same version of reality. And that is the first part of the solution. One connected operational picture built from the physical events already happening across the value chain and represented it virtually. But let me anchor this with something more practical, a hypothetical pit-to-port case study. For example, it's Monday morning. There is a vessel with a loading window opening on Sunday. 55,000 tons of product already committed against a customer contract signed months ago. Let's assume that rail capacity is fixed, plant availability is a little bit under pressure, and everything upstream of that vessel now has one job, really just to make sure that the shipment leaves on time. Now, none of the questions on this slide are especially difficult on their own. In fact, most operations can answer each one reasonably well. The real problem is that they are usually answered by different people from different systems in different formats and at different times. So as we go through these, I'd like you to ask yourself a silent question. Who in your organization answers this? How quickly and from what source? So first, the mine. Are we producing enough and at the required grade? The fleet. Are trucks and loading units achieving the required production rate? Plant. Is processing output on target against the plan? Inventory. Is enough saleable product available right now? Logistics. Are road and rail movements keeping pace with the production? And port. Will enough material arrive before the loading window? And then we get to the two questions that matter most commercially and which are deliberately highlighted in red. First being management, and they want to know, where is the binding constraint this week? And secondly, commercial wants to know, is the contract at risk? And who needs to know today? Those two questions are almost never answered by one system because they are inherently cross-functional. They depend on the interaction between production, inventory, logistics, and port readiness. And that is the critical point here. The issue is not that these questions are hard individually, it's that no one place holds all these 8 answers simultaneously. So nobody can clearly see how one issue affects the other. Production may look fine, while inventory is wrong because material has been misclassified. Logistics may be on schedule, but while the port is facing a quality or stock readiness problem. So if you can answer all 8 of these before lunch on a Monday, confidently, from one connected picture, you are in I would say, a small minority. And I would genuinely love to hear how in the Q&A. Because this is exactly where digitalization starts to prove its value, not in showing one department its own performance, but giving the business a single view of whether the shipment will actually be delivered. And with that in mind, let's move on to what happens when one upstream event suddenly sort of changes the entire picture, hypothetically. So let's stay with the same hypothetical shipment and move from visibility into action. 6:10 a.m., the secondary crusher goes down. In a disconnected operation, someone has to notice the failure, someone else has to understand the production impact, inventory has to recalculate the shortfall, logistics has to be informed, and commercial often finds out last. In a connected operation, that change starts immediately because the availability change is already a digital event. So, for example, at 6:12, the production forecast is recalculated. At 6:13, the stock projection drops below the parcel requirement. 6:15, the shipment is flagged as at risk, and at 6:20, logistics can now resequence rail capacity or draw from alternative stock. And at 6:25, decision makers are notified, and this is where the real value sits, that in a matter of 10 minutes, action can be taken and decision can be taken to mitigate the impact of the downtime. So the value is not the alert. The value is that the logistics plan can still be changed while options exist. So at 6 days out, you can resequence rail, draw from another stockpile, adjust the production plan, or speak to the customer. 6 hours out, now the options narrow dramatically, and often the conversation becomes more of a commercial one rather than operational. And the final step is important culturally as well. A system that simply says shipment at risk creates another meeting. A system that says shipment at risk, here are 2 mitigation options, their operational impact and their cost, supports an informed decision. And that is what the buzzword is. It's a smart system that achieves that. And that is really the proof of end-to-end visibility. One upstream event visibly and automatically changes the downstream commitment. So everything I've shown in the previous 2 slides was hypothetical. Relevant, but hypothetical, and deliberately so. So we could isolate the operating principle. But the same model has been applied in a real deployment, and this is achieved by Reactore and MineOne in the last couple of years. In this use case, the challenge sat at the commercial edge of the mining value chain. The organization was sourcing, moving, and selling material to international customers, but the evidence trail behind each shipment was fragmented across their production records. Weighbridge data, their lab results, transport movements, and shipping information. So although each part of their operation functioned, every shipment was become a small reconciliation exercise, finding the records, matching the movements, validating the tons and grade, and determining essentially where the commercial obligation actually stood. The design principle was exactly the same at the as the digital thread concept that I'd mentioned earlier, except here the thread was anchored to the commercial deal. A contract creates an obligation. That obligation consumes inventory. Inventory is created through production or sourcing. Physical movements change where that inventory sits, and ultimately the shipment just charges the obligation. Once those relationships are modeled in one shared record, the reporting no longer has to be reconstructed afterward. It becomes a consequence of the operational data itself. So in this deployment, we integrated with 10 source systems and consolidated them into one viable commercial record, with the material tracked across 5 value chain stages, while external parties such as transporters, warehouse facilitators, port and finance stakeholders could participate through the same operating environment with an air-gapped distinct portal that they could log into. So this was a use case whereby we actually achieved the outcome by providing a system that was used by multiple entities, not just the client itself. And that was one of the keys to our success. The important outcomes here are qualitative and mechanistic. Traceability here improved because each movement was linked rather than simply filed, and the reconciliations became faster because supporting evidence was attached. As these sort of transactions updated with the various stages, management confidence improves here because everyone is working from the same sort of source of truth, the same number. And the external stakeholders could also be given far more consistent and timely evidence information as well. And they themselves could play an active role in using the system to enable this through dedicated portals. There's also an important scalability point. Manual reconciliation has a capacity ceiling determined by the number of experienced people available to do it, the human factor, the skill factor. However, connected processes allow transaction volumes to grow without the reconciliation effort having to grow at the same rate. That's a very important distinction. So the broader message is that end-to-end visibility should not stop at the mine gate. The same connective principles can extend all the way through logistics, shipment, and commercial fulfillment, giving the organization one continuous operational and commercial record from stockpad to customer. So we've looked at the problem, walked through a hypothetical scenario, and then shown how the same connected principle has been applied in one of our real deployments. The next few slides are about practical principles and guidelines we've used and we recommend for building this sort of capability in your own operation. Not product features, but the operating disciplines that matter, even though they are the disciplines and the dimensions in which we do so generally architect our solutions. The first is measurement. You can't improve what you don't measure. And the first two columns here, operational KPIs and logistics KPIs, are already well understood and probably recognizable to most of you in the audience. You have your usual suspects, equipment availability, utilization, cycle time, tons moved, and of course, turnaround time and beyond. And these are important, and I'm not suggesting we stop measuring them. In fact, I would double down on that. The third column, however, is different. These are end-to-end KPIs, and by definition, they cover several functions. And that is why they are harder to produce and why in many operations they still sort of end up being reconciled manually. I'll highlight two that I think are particularly useful, and that being mine to port lead time and forecast shipment readiness. Mine to port lead times exposes dwell time and often sits between departments and is no obvious owner. Forecast shipment readiness is even more useful because it converts all the upstream activity into the forward-looking question management actually cares about. Are we going to be ready to ship? Another one I like is exception resolution time. How long between something going wrong and somebody actually deciding what to do about it? That is effectively a measure of organizational latency. And the warning at the bottom is important. As mentioned before, local optimization can improve departmental KPIs, but it can actually make overall system worse. Now that may seem counterintuitive. I'll give you an example. You can maximize truck utilization, for example, while continuing to feed a stockpile or crusher that is already constrained. The fleet KPI improves, but delivered cost per ton gets worse. So the practical advice is simple. Choose 3 or 4 genuinely end-to-end KPIs and give each one a named owner with authority across the departmental boundaries. Because if the KPI stops at the boundary, the optimization usually does too. And that requires a bit of paradigm shift in terms of how management structures are set up in a mining environment across the value chain. Now moving on to the concept of the virtual control tower. So once you have connected data and end-to-end KPIs, the next practical principle is this. Do not build another dashboard. Build a decision system. Now, most mining operations already have more dashboards than people have time to look at. Dashboard fatigue is a real thing. I've seen it firsthand. Dashboard number 14 rarely changes the operation. A useful test is to ask whether the system can answer these 6 salient questions. What is happening? What should be happening? What is different? Why is it different? And what happens if nothing changes? And finally, what action should we take? Now, most dashboards will answer the first 1 or 2. A genuine control tower should progressively answer all 6. And this is the design principle in which our system and, ironically, our dashboards are modeled against. And that progression on the right matters. You cannot diagnose issues without its underlying context. You can't predict without reliable historical data, and you cannot recommend an action unless the system understands the operational constraints and the options available. Context is king. So trying to jump straight to prediction or optimization without building those foundations is usually where these initiatives fail. Very ambitious, but running before learning to crawl or walk. There is also an organizational dimension here. A virtual control tower is only useful if somebody has the authority to act across the functions it is monitoring. If the system identifies, for example, that the plant is the constraint, but nobody in the room can influence the plant plan, then the inside changes nothing, becomes toothless. So technology exposes an organizational operational constraint where governance stands to resolve it. And importantly, the first 3 stages, monitor, detect, and diagnose, do not require any fancy predictive analytics or AI. They require good integration, context, and solidly modeled workflows. And that gives us a good foundation. The next question is where AI generally adds value on top of it. And I'm sure a lot of you are wondering when AI was going to come into the picture, and I will certainly address that in the next slide. So first and foremost, this is not an AI webinar. It requires its own point of discussion, but I will touch upon it because it is certainly relevant in the age in which we are living in right now. And I'm not going to make any claims here that underlying data cannot support. I'm going to keep it grounded. Where AI does become generally useful is once the operation already has connected and trusted data foundation. The use cases here are deliberately practical and a little bit mundane. So first you have prediction. Prediction means things like production forecasting, ETA prediction, downtime risk, inventory forecasting, and possibly shipment risk prediction. The next is detection and diagnosis. And this usually means finding anomalies, reconciliation differences, data quality issues, and helping people get to root cause faster. And then assistance is the more visible layer, asking operational questions in plain language, generating routine reports within seconds, or recommending a dispatch or logistics response. A simple example is ETA prediction. If a port planner knows 2 days earlier that a rail movement is going to miss its expected arrival, the intervention is relatively cheap. You can resequence, draw from another source, or adjust the plan. Finding out when the rake is already late is much more expensive. But the most important part of the slide is actually the sequence at the bottom. Connect, contextualize, govern, analyze, automate, optimize. Govern is often the step people skip. You need agreed definitions, clear ownership, data quality rules, and a trusted master source for each fact before you ask a model to make recommendations. You don't want to be stuck with a garbage in, garbage out scenario. Because at the end of the day, AI is ultimately just a multiplier. Give it good operational context and it can accelerate good decisions. But give it inconsistent tonnages, conflicting inventory figures, or poor master data, and it will produce inconsistent answers faster and often with more confidence. And this can be particularly damaging to operations that pivot and make decisions based on this. So fragmented data pool plus AI is not intelligence. It is accelerated disagreement. So for most pit support programs, the early value still comes from connection, context, and exception management. AI is the compounding return on the foundation. It's not a substitute for building it. And that is a very important principle when to live by when looking to incorporate AI into your technology roadmap. Discussing about AI and analytics is really a discussion linked to a larger discussion of digital maturity. And this slide represents that, and it's really just about sequencing. So digital maturity is a staircase, and one of the most expensive mistakes is trying to skip the steps. I'd ask you to replace your own operation somewhere on this journey. In my experience, many minds sit somewhere between connect and contextualize and visualize, with one or two functions operating much further ahead. Perhaps maintenance has a very advanced condition-based monitoring predictive maintenance system, or mining has a very sophisticated dispatch optimization algorithm. These advanced pockets are useful, but they also expose the problem. A department operating at level 5 inside an organization that is still largely at level 2 can make excellent local decisions without materially improving the performance of the value chain. So for me, level 4 control is where the economics really start to change. Observing and visualizing are necessary foundations, but control is where you begin intervening early enough to protect an outcome through alerts, workflow, and exception management. And that is why I would avoid building a program where all the business value is deferred until 5 or 6. Each level should solve a real operational problem to justify the next. This is also not a rip and replace journey. Your fleet system, ERP, maintenance platform, and other investments can remain in place. The objective is to connect and contextualize them through a shared operating model. And maturity will rarely be uniform. You might be at level 4 in fleet and production, while logistics is still at level 1 or 2. That's normal. The practical lesson is to invest in the weakest important link in the chain, rather than automatically just investing in the most advanced or exciting technology. So strategic thinking is important here. And most importantly, you do not need to reach level 6 to start to create meaningful value. So taking on the further discussion regarding practical guidance, if there was one practical message I would leave you with, it is this: sequencing beats ambition. And this sequence is deliberately unglamorous. Step 1 is where many programs go wrong. If the initiative starts with a technology now, a buzzword, digital twin, data lake, AI platform, it becomes very difficult to prove what actually improved. Start instead with a costly operational question: constraint or commercial outcome. Steps 2 and 3 are equally important. Map the physical process, then map the digital process. That sounds quite basic, but it is where you discover how the operation really works. And the spreadsheet nobody documented, the WhatsApp group coordinating a handoff, the phone call that sort of authorizes a movement. These are often the real integration points. Step 4 is about honesty. For each important decision, ask, is this based on measurement or an assumption? The places where people rely on estimation, stale data, or manual reconciliation are often your highest value opportunities and the lowest hanging fruit for improvement. Then build the minimum digital thread. It doesn't have to be everything, just a few events, critical events, I should say, needed to answer one important question, end to end: source, movement, stockpile, dispatch, shipment. And when you put that information into the workflow, make sure it reaches the person who can actually act upon it timelessly. Step 7 is to measure the result. And when you put that information into the workflow, make sure it reaches the person who can work with it, and baseline before you start. Measurement is not only the operational KPI, but also the manual effort, which is currently spent reconciling, checking, and chasing the information. If you cannot show what improved, then the program will struggle for funding, even if the technology worked, which is something I've seen a few times with other technology that's been adopted at mining operations. Then scale deliberately. Add optimization, automation, and AI only once the foundation is proven. That icing on the cake will only have value when the cake itself is of a good quality. And I would finish with the line at the bottom, which because it is the best test of a first phase. And this is a key prism to run any initiative through. It should be small enough to finish and important enough to be missed if it is stopped. Now, before we go to questions, if you forget everything else from the last 40 to 50 minutes, keep these 3 ideas. The first, mining logistics is one system. Every department in the chain can hit its own targets in a week where the shipment is still late. If that can happen in your operation, then you are managing the links very well, but not necessarily the chain. The second, visibility only matters while you can still act. For every important decision, compare 2 things. 1, how quickly you could intervene, and 2, how quickly you actually find out there is a problem. The closer you can bring these 2 together, the more valuable the information becomes. And thirdly, connect decisions, not just data. System integration is only the means. The real outcome is that a change in the pit reaches the person managing production, logistics, or the shipment while they still have options. I'll leave you with this. The advantage will not belong to the mine with the most systems. It will really belong to the mine that can connect its operation, understand its constraints, and act fastest. So I'll leave you with one sort of internal call to action. If you want one practical exercise to take back to your own operation, pick a single shipment or production commitment this week and time how long it takes to answer the same 8 questions we used earlier. That exercise will be quite useful and alone will often reveal where your real visibility gaps are. So that brings us to the end of the formal presentation. We have a little bit of time left, and I would much rather spend that time on your questions than on more slides. Please use the Q&A panel, and if your question is specific to your own operation, ask it anyway, because there really is a good chance that other people in the call or in the webinar are dealing with exactly the same issue. I thank you again for your time. Thank you, everybody, for attending the webinar and enduring that. Hope it was useful to you. Definitely grounded in practical reality and what I've experienced firsthand. There are 1 or 2 questions that have come through. Perhaps, Pratush, I can take one of them quickly. So a question was raised regarding, does the system accommodate the various grades of ore requirement versus deposit availability, limestone, coal, iron ore, etc.? And can it forecast based on the average volume of production in the recent past? So yes, that's a really great question. We can certainly track different material types. It's just really a data source, and that will be by linking through your mine planning systems, your limb systems, your plant data, your equipment data. And yes, it can, for the short-term planning forecast, uses sort of weighted averages and other sort of machine learning principles. But obviously the higher quality of source data and specialized systems that are sourcing that data, the better the resolution and the better the accuracy of these forecasts, and the longer we can actually take that forecast forward. So it's a complex topic, but it's certainly something that we have achieved and can achieve with the use of our system. I'm not sure, Pratush, I think you've got a couple of other questions that have come through. Perhaps, I'm not sure, you can play traffic controller and let me know whatever you think is necessary.
Yeah, definitely. I mean, there are a few questions. I don't know if we can answer all, but definitely we'll get back to you on the questions that you have asked through email. Please check that out. But yeah, one question, and as we expected now, after the second part, most questions are pertaining to Mine 1. So one of them is, how does Mine 1 maintain operational visibility when connectivity across the mine is intermittent or unavailable? Is something that is very common in most mines. Yeah.
Yes, that's a very good question. And look, for the proper digitalization initiative, it is recommended that a mining at the operational level has a degree of connectivity. But we do recognize that that is a heavy sort of capitalized investment that a mine has to do, and then the ROI might only come later down the value chain. But essentially, yes, we do support mitigating features in our tech stack to achieve that. So we obviously have offline capability for our field applications. We have hardware that can work in a store and forward capacity. So for example, a haul truck that is visiting an excavator will take a data payload through to the excavator, transmit instructions, and vice versa. The excavator telemetry or data will then be passed on through a store and forward mechanism to the truck, and the truck will literally carry the mining payload as well as the data payload through to an area where there is connectivity, where the data can be sent through to the server. So yes, we do recognize that mining operations are difficult, they're dynamic, they don't always have the perfect connectivity. And we also ensure that our field apps and telemetry data acquisition works as light as possible. So if you're running at limited bandwidth, and perhaps you're having not so great video quality, as you can see now in some cases, we obviously then mitigate that with the way we set up our system. So it's something we are cognizant of, and we are always trying to be practical in how we implement our solutions.
Yeah,
Thanks,
thank you,
Pratush.
Julian,
Question?
for answering that. And that is one of the questions that I think in all the webinars that we have done, this offline thing is the offline capability or low network area questions are always popping up, because that is common across most of the mines, I would say. I'll move to the next question. Maybe we can take two more along, including this one, because of the time that we have. So what are the types of systems and equipment that one can typically integrate with across the entire value chain?
Oh, that's a very good question as well. So look, we can connect with anything, any system or data source that can produce viable data. From Reactore side, from the ground up, we've developed our platform with the ability to be integration ready. We're technology agnostic. We're not tied into, say, a particular OEM's ecosystem where we can only work with A, B, or C. We can work with anyone as long as they share the data. So from our side, it's a variety of systems, from IoT to instruments to sensors to your ERPs, and everything in between, your lab systems, your SCADA plant, your equipment, additional geotechnical monitoring sensors that may be very important for safety and infrastructure. Anything that produces data, I mean, your coffee machine, anything really that produces data, we can connect with, so to speak, and leverage that as the mine needs it, not just for the sake of it, but incorporate it, ingest it, contextualize it, as mentioned in the presentation, and then leverage it in a way that can allow for the right people to get the information from those data sources to make quality decisions that can impact on the ROI of the system that we are installing. So that's the whole premise of how we work.
Yeah, that's right. Thanks for clearing that out as well. And then we remember one question we got at the beginning of the session, and we said kind of the second part would be answering it. That was on what would you be implementing first when it's what are the capabilities that we would normally recommend implementing first for a mine starting their journey. I think that
Sure.
has already been answered. Do you want to take it up again, or you want to move to the?
I think the presentation has covered it. We have Mine One. If you look at our website, it's a honeycomb of modules, and you could think of it almost like our shop for module A, B, and C, D, and you could do that. I mean, our modules are designed to solve real world problems. But as per the webinar, you really need to first identify where there are the most pressing needs in your mining operation, whatever it may be, and then work backwards. And how can I solve that and mitigate? And that's what we can assist you with. As a part of our service delivery and offering, we can assess your as is, and we can make a 2B, and we can create a matrix of, value versus effort, cost versus benefit. And you can see what are the low-hanging fruits, what are the things that cost the least, and have the highest impact. And let's tackle that first, and climb that digitalization maturity staircase, as what we often describe ourselves as a digitalization partner for our clients. So we walk a journey with them. And often with many of our clients, we'll start with one project and we'll end up having 3, 4, 5 projects as a long-standing relationship with them. And they will take on more systems and more modules that solve the real world problems. And to solve this, yes, we've structured our product portfolio in a honeycomb structure to show that they connect with each other, but they can also connect with what the mine already has. So I won't recommend anything particularly first. Always maybe start with what costs the most. Mining is mechanistic. It's sort of you have your yellow fleet, you have very expensive equipment and machinery. Start at stuff that can maximize on the utilization of that equipment and the life of asset of that equipment, and start there. Or look at safety, look at the cost of life as well. That's another very important thing I personally believe in. And safety systems, which are underrated, I think it's something you can also look into that as well. So, but it's a whole topic on its own. It's for another webinar, Reactore, but a good question nonetheless.
Yeah, definitely. And we'll just squeeze in one more question before we're wrapping up. But before I ask the question, I just want to ask the audience if there's anybody who would want to directly come and ask the question, you can raise your hand. We'll give you the mic access and you can, give your feedback, or you can ask your question directly. Yeah, the last question before somebody raises their hand, it's how can Mine One, or how do we integrate with operational technology without creating the cyber security risk or becoming a dependency for plant and mine control?
Yeah, it's a good question. Look, we have the constant and sometimes understated risk of IT and OT security. And this is something that we've encountered and had to deal with at many operations that have actually faced cyber attacks during and after implementation of our and other systems. So at Reactore, we are first and foremost ISO accredited for information security management 27001. And we obviously have a very secure tech stack in how and role-based access control and a lot of mitigations that we put in place to prevent uncontrolled leak of sensitive data. And also for the cyber physical interfaces we produce where control is requested, where we activate a ventilation system based on a gas reading. These are areas and sections we take very seriously, whereby we assure that there are a lot of controls and measures in place that prevent exposure through our IT and OT security strategy. So yeah, to summarize, its access is role-based. Integrations can be brokered across segmented networks. Operational master data changes are auditable. We have an audit trail of all changes. We are tracking integration monitoring in our system and a live sort of monitoring dashboard. So we're being very proactive about this topic, and not to be underestimated, because a lot of minds don't look at it, but when it hits them, impacts them, then they realize this actually is a major issue where there's been an IT or OT security breach. So it's a good question, whoever raised that. Thanks for that. I didn't expect that one, so thanks.
Yeah, probably a topic for our next webinar already asked over here. Thank you so much for all the questions whoever has asked. And we have a few more questions, but in the interest of time, we'll send you an email with the answer that we have to your questions. Asking once again before we wrap up, if there's anybody who wants to come and speak, you can raise your hand. Otherwise, we are good to go and wrap it up.
Thank you, Pratush, and
Yeah.
thank you to all who attended. I appreciate your time, and hopefully it can play a difference and have meaningful practical value in how you perceive and manage your operations. So, and whatever you may be doing. So thanks again to everyone who joined. Thank you.
Thank you so much. Have a really good day and really good week ahead.